Welcome back. We are to the third installment of chapter 6, and we're going to deal with exponential functions. So if we have when x equals 0, y equals 1, when x equals 1, y equals 2, x equals 2, y equals 4, 8, and so on, our function that we're looking at is 2 to the x power. Now, please note that this function is has a constant base and a changing exponent. So this thing actually is going to get really large really fast and also very, very small very fast. In general, this function, the domain of this function is going to be all real numbers. So there are no boundaries, meaning negative infinity to positive infinity. And the range is going to go from 0 to infinity. So let me put this in that notation. And we are going to do a couple of graphs, and let's set up an XY table. 0, 1, 2, 3. So this is f versus g. So this is f of x. So I'm here 2 to equals 2 to the x. So when x equals 0, y is 1. When x is 1, y is 2. X is 2, 2 squared is 4. X is 3, 2 to the third power is 8. And this is going to and actually, let's cross that 1 here. This graph is going to look like this. It is asymptotic, meaning there's an asymptote at the x-axis. You can see it gets smaller and smaller and smaller. In fact, it's going to get closer and closer and closer to the x-axis, but we'll never touch it. Hence, the range is like this here. And the other graph that they have is g of x equals 1/2 x. So this is going to look similar, except it goes exactly backwards. So you can see as x gets larger here, y is dropping down to 0 very, very quickly. And the exact opposite is happening over here. It's exploding on this side. So here's an idea of what our graphs are going to look like. And our exponential functions, when b is, it can't be 1, but when b is positive, so let's do this. If b is bigger than 1, I should say, then the graph is going to look like this first one here. You can see b is 2 in this case. So in general, it's going to look like this. And it's going to cross at 1. All of these cross at 1 unless they're shifted somehow. In fact, all graphs go through 0, 1. There. They're continuous. The x-axis is horizontal asymptote on one side only, so it's only on this side. Now, just to be clear, if b is between 0 and 1, it's going to look like this one. So again, this is going to go here and cross at 1. And they're one-to-one functions. You can see they pass the horizontal line test. Every horizontal line is going to cross both of them only one time. All right. We have a new number to consider. This might have been introduced to you in intermediate algebra, maybe not. But we have this definition here. And I've actually put that into my y equals. You can see 1 plus 1 over m raised to the n power. And I'm going to start out by saving 1 in for m. So 1, let me show you what I'm doing. Store, and then alpha m. Oop, that's a W. Oh gosh, let's make sure I have this right here. Yep, I think we're looking good. All right, so I want to store 1n for m. And then I want to run, like I did in a previous video, vars, yvars. Here, and I'm just going to hit enter. And it became 2.000. So let's put 100. So 100 store m. And now let's run it again. So y1, and I hit enter. And you can see I'm getting this number here. In fact, I'm going to crank it up to a really big number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. Why not? Store into m. And let's run this again. Now, this number is a very famous number. This is the number E, named after Euler, actually, a famous mathematician. E is very important. Here's e to the x. It's between 2 and 3, you can see. Sometimes it's written this way, like you're writing code, computer code or something. Often that's the way that it is, or even in big physics formulas and stuff. So with that done, let's do an example. So we want to come up with, and we have our generic function, y equals a b to the x. What we want to do is use these 2 points that are on this graph to figure out what a and b are. So I'm going to start with 3/25 equals a b to the -2 power. And I'm going to get a by itself. A equals 3/25 b to the +2 power. Remember, that's 1/b squared, so I just multiply both sides by b squared. Similarly, I'm going to take 375 equals a b to the 3rd power and divide both sides by that. I get a equals 375 b to the -3rd. And a is going to equal a, so I'll set them equal to each other. 3/25 b squared equals 375 b to the -3rd. And I'm actually going to multiply both sides by b to the 3rd. So I get b to the 2 times b to the 3rd, and multiply that by the reciprocal of that. So let's do that real quick. So 375 times 25 divided by 3. 3120, yeah. So 3125. So remember, when you have the same base, you add the exponent. So this is b to the 3rd, 5th equals 3125. And if I raise this number to the 1 divided by 5 power, take the 5th root, basically, I get that b equals 5. Well, now I can figure out what a is. So a is going to be 3/25 times 5 squared. So it's like a, that's 25/25, so a is just 3. So my function is 3 times 5 to the x power. Not too bad. It's basically solving a nonlinear system of equations. Example 3, starting with the graph of y equals 9 to the x, write the equation of the graph that results when it shifted upward. Okay, so let's take a here. So we're going to get f of x equals 9 to the x plus 7. So that moves the whole graph up. B is shifted 7 units downward. I'm going to change this to the left. If it's going to the left, that's going to give me 9 x. To the left, it seems like that's negative, but it actually is going to have to be here. That's the opposite sign. If you remember, we've done that quite a bit, actually. And it's reflected about the x-axis and the y-axis. That is going to be negative 9 to the negative x. Not too bad. And example 4, we're going to graph the function. And I'm going to start with, and we'll talk about domain and range and asymptotes and stuff like that in a second. So let's start with the generic graph. So the generic graph, I'll draw in black actually. Is here. Now, the -2 up here means that I'm actually going to be moving the graph 2 units this way. And that's going to pass through here. So everything's been shifted over. And then this last one is going to be the shifted over, but we're going to have our new asymptote is down here at y equals -2. So it's shifted over and shifted downward. And the domain is here. Is still all real numbers. That doesn't change. The range, however, used to be 0 and up, not inclusive, but now it went down to -2 to infinity. And our horizontal asymptote is right there, y equals -2. We have a rule. It says if a to the x equals a to the y, then x must equal y. Meaning if the bases are the same, then the exponents must be the same as well. So let's start with a here. Oh, and by the way, this last one here, for some reason I erased it on mine. Yours should have it back. This is 15.2.7 raised to the 0.006 t. I'll come back to that. Okay, part A. 2 to the 3x equals 4 to the x plus 1. Well, this is base 2. I can turn that into base 2 as well. And if you recall, if you have a power raised to a power, that means that I have 2 raised to the 2x plus 1 power multiplied. And now you can see the bases are the same, which means the exponents have to be the same. I'm going to go and distribute that. 2x plus 2, which means x equals 2. Let's do b. b is e to the x squared equals e to the 3x minus 2. Bases are the same. This is that same number e, the 2.7 and change that we came up with the calculator. So x squared equals 3x minus 2. I have a quadratic, get everything equal to 0. In this case, we have 2 answers, 1 and 2. Part C. So this is e to the 2x plus 3 equals 1 over e to the 4th. That's easy. I'm just going to rewrite this e to the -4th power. So now the bases match, which means the exponents have to match. And it makes sense that it's negative because we definitely have a negative piece in there. Part D, again, I'm going to use this formula here. Let me first have a little more. And basically, they want to know, and I'll rewrite it here, 15, 2.7. In actuality, this number here is actually the number E in the real formula. And we'll learn how to build an equation like this in a later section. And they want to know a certain type of bacteria grows at a daily rate of 0.6%. That's that number there. If 15 bacteria, there we are present today, how many will be present in 110 days? So they basically want to know at T equals 110. So let's get that. So I'm going to do the exponent first. So 2.7, just recall, this is the exponent button right here, raised to the 0.006 times 110, and then times 15. Yeah. So y is going to be 28.89. So we'll say 29 bacteria. Right. So it's new, it's weird, I get it, but it's manageable.